Good morning, students. Here's a warm-up. Why don't you hit pause, work these, and then hit play, and I will explain them. All right, number one there. First, remember, you take the value of c here, plug it in, which is going to give you, in this case, 0 over 0, sine of 0 over 0. That is indeterminate. Remember that the denominator's got to be the same as the top, so what I'm going to do is multiply this top and bottom by 2. This will then give me 2 times the sine of 2x all over 2x. By the way, that's the same as 2 over 1 times the sine of 2x over 2x. And then I just take the limits of each one of those individually and then multiply them. The limit as x goes to 0 of 2 is 2. The limit as x goes to 0 of sine of 2x over 2x is equal to 1. And that's a formula from way back in chapter 1. The limit is 2. Number 2, take 4, plug it into the top and bottom. Again, this gives you 0 over 0, which is indeterminate. The giveaway is you've got a radical and a difference, so I'm going to multiply top and bottom by the conjugate, root x plus 2. What that's going to give me then on the top is x minus 4, because the middle term drops out. X minus 4 in the bottom times root x plus 2. These cancel. I then try to plug in my value of c again, and what I get is 1 over 4. That is my answer. Doesn't matter that it is one-sided. Remember, you treat two-sided and one-sided limits exactly the same, unless you're approaching a vertical asymptote. And speaking of which, on number 3, when I take 5, the number 5, keep in mind this is from the left, not negative 5, so I plug that in. What I get is 10 on the top, and I get 0 on the bottom. That is not indeterminate. What that's telling me is that it is undefined, meaning there is a vertical asymptote on this curve at 5. Without that little minus sign there, the answer would be does not exist. However, it is one-sided, which means my answer will be either positive or negative infinity. We need to investigate to determine what it is. The top is 10 when I plug in 5. Now, if I take a number to the left of 5, which is 4.999, and I square it, I get a number just slightly under 25. I take 25 from it. That gives me a very, very, very small negative number. 10 divided by a negative tiny number is huge and negative. My answer is negative infinity. All right, my people. Today we're going to do section 3.1. We're starting chapter 3. Section 3.1 is extrema on a closed interval. So let me explain what that means. So first we're going to start out with a curve that is restricted over some value of x. So let's say I go from, say, a to b. It could be like negative 1 to 5 or something like that. They're just going to give you a portion of the curve, and it's going to be a closed interval, which means it includes the endpoint. So those are closed circles. And you can think of extrema on a closed interval as just being the highest and lowest points over that interval. So we're looking for absolute maxes and absolute mins. So in this drawing, this point right here would be the highest point anywhere from A to B on that curve. So we will call this the absolute maximum. That's that point right there. Then we're also looking for the lowest point over the interval from A to B. So this point right there is the lowest point. That is going to be the absolute minimum. And that's really all you're doing in section 3.1. You're looking for the highest and the lowest points. Let me give you another picture. The picture might look something like that, where I've got a closed interval going from this x value to this x value. By the way, those x values will be given in the problem, and what I'm looking for in this picture is the absolute highest and absolute lowest points. So my absolute maximum in this drawing would be this point right there. And in this case, let's just say that these two y values are the same, not to scale. And in this case, you'd have an absolute minimum here and an absolute minimum right there. So what you're going to be looking for is you're going to be looking for those points. Again, the highest and the lowest points over a closed interval. Now, they're not going to give you pictures in section 3.1. You're going to have to come up with those points yourself using calculus. I'm going to show you how to do that right now. All right, let's take a look at these two graphs. In order to find potential highest and lowest points, this is what we're going to do. And I think these two pictures illustrate where the highest and lowest points could actually occur. If you look at this first picture here, the one on the left, you'll notice that the lowest point occurs right here at an endpoint. Now we can also have a picture that looks something like this, where in that picture there, the lowest point is this down here, and the highest point is at the other endpoint. So my absolute extremas could occur at the endpoints, so I need to check those. So let's go ahead and make a list of this. Absolute extrema could occur at the endpoints. Those are the first two drawings that I just gave you. You got to check those. Where else could absolute extrema occur? Well, if you look at the drawing on the left, I think you would agree that the highest point, as we said before, is right there. If you think about this from a calculus standpoint, that's actually a hilltop in that graph. And if you think about calculus, or how calculus applies to hilltops and valleys, what I want you to think about is that you actually have a slope on that curve of 0. So that is a potential area where you could have a highest or lowest point. So that's where you need to check. So let's add this to our list. All right, that's where f prime of x is equal to 0, because I remember from last chapter, right? F prime of x is our slope machine. And if our curve actually has a value of 0 for its slope, it could potentially be the highest or lowest point over that closed interval. So we need to check those as well. Now, if I look at the picture on the right, as we said before, my two endpoints were, in fact, both absolute minimums. So we've already got that on our list. But you'll notice between this x value and this x value, there is no point where that curve has a slope of 0. However, this point right here is an absolute maximum. Now, if you think about what's happening with calculus, that is a sharp point. And in regard to slope, remember at sharp points, there is no slope. So we need to add, or we need to check those values as well, because sharp points could be a place where you've got a highest or lowest point. So let's add that onto our list as well. All right. So I've got 3 places that I have to check that could potentially be the highest or lowest point. First, I'm going to check the endpoints, and then I'm going to use the derivative and find out where that's equal to 0 and where it is undefined. All right. Now, these second two here, where f prime of x is equal to 0 and where f prime of x is undefined, the x values are called critical numbers. And I'm going to refer to critical numbers again and again this semester. So we're looking for endpoints and critical numbers. All right, so let's go ahead and work an example, and hopefully this will become a little more clear. So let's start off just by talking about critical numbers, because the endpoints are going to be given in each problem. Finding critical numbers is key, because those could potentially be the highest and lowest points. So let me give you an example. How about this? Y is equal to, actually, let's call this f of x is equal to 3x to the 2/3 minus 2x. Now again, they're not going to give you the graph. You're going to have to come up with the critical numbers on your own. So remember, critical numbers come from where the first derivative is equal to 0 or where it is undefined, which means I need to derive this function. So let's go ahead and do that. All right, and as I start to work through this, remember 3 is a constant. The 2/3 comes down to the front. That's going to be 3 times 2/3. That is 6/3, or 2x, and then I take 1 away from the power. That is negative 1/3. And then I've got minus 2, because the x goes to 1. All right, now in this chapter, in this section, I think you should simplify this into a single fraction because it's going to make finding where it's equal to 0 and where it's undefined much, much easier. All right, so let's go ahead and clean this up. This is the same as 2 over x to the 1/3 minus 2 over 1. This, again, is f prime of x. All right, let's get a common denominator here. I'm going to multiply the second one by x to the 1/3 in the top and in the bottom. And that's going to give me an f prime of x is equal to 2 minus 2x to the 1/3 all over x to the 1/3. All right, now, critical numbers are going to come from where the first derivative is equal to 0 and where the first derivative is undefined. And if you recall from last chapter, zeros come from the top of a fraction and undefined comes from the denominator. So what you want to do is you want to set the top and the bottom of the first derivative equal to 0, one at a time. So let's go ahead and do that now. Let's get rid of this. First, I'm going to find out where it's equal to 0. That is 2 minus 2x to the 1/3 is equal to 0. I'm going to add 2x to the 1/3 to both sides. I'll then divide by 2. And then what I want to do is cube both sides. So when I cube the 1/3, those cancel, and I end up getting 1. So my first critical number is x equals 1. This is where the slope would be equal to 0. This would be like a hilltop or a valley. And then I also want to check where it's undefined. So I'm going to take this, and I'm going to set that equal to 0. I've got x to the 1/3 is equal to 0. I cube both sides. I get x is equal to 0. So that is where my first derivative is undefined. Both of these are critical numbers. So critical numbers of the original f of x are 0 and 1. All right, now in this problem I ask you to find the critical numbers of f of x. What if I use the same function here and I asked you to find the absolute extrema, which is what we're going for in this chapter. So give me 1 second. Let me copy this problem and rephrase the problem just slightly, or the question just slightly. So now we're looking for absolute extrema of f of x is equal to 3x to the 2/3 minus 2x. So remember, what I need to do is I need to check the endpoints and critical numbers. And we know from this problem here, or the work that we just did on the previous screen, I should say, that my two critical numbers are 0 and 1. So those are going to go on my list. So I've got 0 and I've got 1. I need to check both of those. So again, these two are my critical numbers. And then I also have to check the endpoints. So I'm going to check -8, and I'm also going to check 8. Now the reason I'm writing these as an ordered pair is because if I'm looking for absolute extrema, I'm looking for the highest point and I'm looking for the lowest point. I won't know which one is the highest or the lowest until I actually find the y values. And if you remember from chapter 2, the y values come from the point machine, right? The point machine. So, because I'm looking for the highest point and the lowest point. All right, so if I take 0 and plug it into my point machine here, I've got 3 times 0 to the 2/3 minus 2 times 0. That gives me 0, so my y value is 0. Go ahead and put that in there. Let's go ahead and check 1. I have 3 times 1 to the 2/3 minus 2 times 1. So if I follow PEMDAS, I cube root 1, which is 1. I square 1, which is 1. And then I multiply by 3, so that's 3 minus the 2 I get when I multiply 2 times 1. And I get 1 for my y. All right, so I got 2 points here, 0, 0, and 1, 1. So far, it looks like 1, 1 is the highest and 0, 0 is the lowest. But I'm not going to know until I check the endpoints as well, because they could be higher than either one of those or lower than either one of those. All right, let's check -8. I have 3 times -8 to the 2/3 minus 2 times -8. All right, we talked through this. If I cube root -8, that gives me -2. I square that, that gives me +4 times 3 is 12, and then minus a minus, that's plus 16. I believe that gives me 28. So I'm going to put my y value right there. At -8, I'm at 28. So this is clearly higher than the other point. So that's looking right now as my absolute max. Let's check 8. Come on, it'll be fun. 3 times 8 to the 2/3 minus 2 times 8. All right, I cube root 8, that's 2. I square it, that gives me 4. Times 3 is 12 minus 16. That gives me -4. All right, so what I'm looking for now, looking for the highest and lowest points. Out of all 4 of these points, you can see that this right here is my absolute maximum, and this one right here is my absolute minimum. So those are my absolute extrema. And that's all you're going to be doing in section 3.1. I'm going to work a couple more. If you think you got it, you can just pause this or stop it. Feel free to rewind, watch it again, show your friends. It's going to be amazing. All right, so let's work a couple of more examples. And again, you can drop off whenever you need to. All right, guys, here we go. So what we're going to do now is, oh, excuse me, I did forget one thing. We're looking for the absolute extrema over the interval from -1 to 3. So again, finding absolute extrema of f of x over the interval from -1 to 3. So again, remember, we need to check the endpoints and critical numbers. So let's go ahead and take care of the endpoints right now. I've got -1 and 3. So we got those taken care of. Now we just have to find critical numbers, and we do that by deriving, right? So this is f of x is equal to x times, excuse me, 3 minus x to the 1/2 power. Here we go. We got to use the product rule, right? Because I'm multiplying x times 3 minus x to the 1/2. I'm going to derive x first. That's 1 times the second function as is. I'm going to add that then to x times the derivative of the second portion, which is chain rule. So I take care of the 1/2 first. 1/2, that takes care of that. Then I multiply that by the derivative of the innermost function, which is -1. And just like we did in the previous example, what I want to do is get a common denominator and then set the top and bottom equal to 0. So I'm going to rewrite these as fractions. This is 3 minus x to the 1/2 over 1. I'm going to add this then to a -1 x on the top and a 2 times 3 minus x to the 1/2 on the bottom. Right, so my negative x comes from here and here. My 1 comes from the top. It gives me negative x. 2 is on the bottom, and then 3 minus x to the -1/2 goes to the bottom as well. So this is my common denominator, the denominator of the second fraction. So you want to then multiply the first fraction by 2 times 3 minus x to the 1/2 power on the top and bottom. And what this is going to give me is f prime of x is equal to 2 times 3 minus x to the first power, because if you have the same base, you add the exponents. So we then plus a negative x on my second fraction over my common denominator of 2 times 3 minus x to the 1/2 power. Now if I clean this up, that is going to be 6 minus 2x plus another x. That's 6 minus 3x on the top, 2 times 3 minus x to the 1/2 power on the bottom. This is my y prime. All right, now remember, critical numbers, once you've found the derivative, come from the top and the bottom. So I'm going to erase this, make a little room here. If I take a look at the top and I set that equal to 0, I get 6 minus 3x is equal to 0. I add 3x and divide by 2. I get x, and divide by 3. I get x is equal to 2 for my first critical number. And then if I set the bottom equal to 0, divide both sides by 2, square both sides, that gives me a 3 minus x is equal to 0. Add x to both sides, I get x is equal to 3 as my other critical number. All right, well, what you'll notice is 3 is already an endpoint, so I don't need to put that, I don't need to check, rather, 3. but I do need to check 2 because 2 falls between -1 and 3. So I'm going to add that to my checklist. So here's the deal. I've got a critical number here, and then these two are my endpoints. You got to check those, and remember, we're checking these into the point machine because I'm looking for the highest and lowest points. All right, let's do this one at a time. I take -1, I plug it into here, my point machine. That is the square root of 4. That is 2 times -1. That gives me -2 for my y. All right, let's take 3 and plug it in. I have the square root of 3 minus 3, which is 0, times 3 on the outside. That gives me 0 here. And now if I plug 2 into my point machine, I get 3 minus 2, which is 1. The square root of 1 is 1, times 2 is 2. And now all I'm looking for is the highest and lowest points. It looks to me like this. 2, 2 is my absolute maximum. And then -1, -2 is my absolute minimum. And we're only judging this from the y values, right? Highest and lowest y values give us the absolute max and the absolute min. All right, people, that does it for section 3.1. I will have the assignment posted to my website. I'd like you to start working on that now. I will take questions if you have them. Have a great day. Thanks.